Example 18, water at 20 degrees Celsius where kinematic viscosity is 1.003 times 10 to the negative 6 square meter per second, flows in a 500 mm diameter welded steel pipe with absolute roughness 0.046 mm. If the friction loss gradient is head loss over length is 0.006, determine the flow rate. So again, let's assume smooth pipe. So head loss over length is 0.006. Then head loss is 0.0826 FLQ square over diameter raised to 5. So let's form head loss over length 0.006 equals 0.0826 friction factor Q square over zero point 0.5 raised to 5. Then let's evaluate square root of F, which is equal to 0.04764 over Q. Then since we will assume first the pipe is smooth and Reynolds number is diameter, mean velocity 4Q over pi diameter square over kinematic viscosity 1.003 times 10 to the negative 6. So Reynolds number is 2,538,863 Q. Then substitute into 1 over square root of F equals 2 log of RE square root of F over 2.51, assuming the pipe behaves as a smooth one. So 1 over 0.04764 over Q equals 2 log of 2,538,863 Q times square root of F, which is 0.04764 over Q over 2.51. We can cancel Q, we can evaluate this part. Write this as Q over 0.04764, so equals 9.366. Cross multiply, Q is 0.4462 cubic meter per second, but we still have to check if the pipe really behaves as a smooth one by computing the thickness of viscous sublayer and compare it with the absolute roughness. Thickness of viscous sublayer is 14.14 times diameter over Reynolds number square root of F. And the Reynolds number is 2,538,863 of Q, and Q is 0.4462. So Reynolds number is 1,132,841. So check F is 0.04764 over Q from this equation, then square to solve for F. Friction factor is 0.0114 if the pipe really behaves as a smooth one. Then we can now evaluate thickness of viscous sublayer 14.14 times diameter 500 mm over Reynolds number square root of friction factor. So the thickness of viscous sublayer is 0.05845 mm, which is greater than 0.046. So therefore the pipe behaves as a smooth one and our assumption is correct. Therefore, the discharge, we accept the discharge 0.4462 cubic meter per second.